about still in the part of rule of differentiation. There are few rules here. Before break, I explained about the rule of constant, derivative of constant, derivative of power of x, derivative of log function, and derivative of exponential function. Okay, again, if we have this function, for example, okay, let's say we have y equal to phi x to the power of 4, and then we need to find the first derivative, dy dx, or y prime is equal to what we can do is we can apply the derivative for the power of x. Okay, this is constant, phi is constant, times 4 the power of x, 4x. Now after we take the first derivative, the power is less 1, 4 times 1, so the answer is 4 times 5 is 5 times 4 is 20, 20x to the power of 3. Okay, that's about the derivative, the how to find the first derivative. Okay, the next one, let's say I have, okay, for example, I have another equation. We can apply a sum of different rule, or differentiating sum and different of the function. Let's say, in other words, if you refer to page 6, let's say I have this function y equal to x to the power of 3 minus 10 plus 1 divided by x to the power of 3. Then we need to find what is a y prime or dy dx. Y prime or dy dx. Okay, in this case, we need to find the derivative one by one, step by step, part by part. In this case, we need to find what is the derivative of x to the power of 3. Okay, for this derivative, this equal to 3x to the power of 2 minus, okay, since this is a constant, the derivative of constant is 0, and plus 1 to the power of 1 divided by x to the power of 3. This is equal to x to the power of negative to the power of negative 3. So this equal to negative 3 x to the power of negative 3 minus 1. Remember, when we take the first derivative, when we calculate the derivative, the power of the x will reduce 1. We need to minus 1, the power of the original power of the function. So the answer is 3x squared minus 0. You can just ignore this number. This equal to negative 3x to the power of negative 4. That is the answer. Then how to find the derivative. Okay. Let's see the next one. Okay, there is one concept named with the product rule. The product rule. So in other words, we find the derivative of the multiplication function, the product rule. Let's say I have two functions. Let's say I have fx times dx. There are two functions here, fx times dx. The first derivative dy dx of this function fx dx is equal to, okay, please refer to page 6, page 6, rule number 10. There is a derivative of for the product rule. Okay, the first step is we just use this formula. This equal to fx times the first derivative of the derivative of dx, d prime x, plus gx times the first derivative of the first derivative of fx. Okay, this one g prime x is a first derivative of the x. The f prime x is a first derivative of first differentiation of fx. Okay, let's say for example, I have this function y equal to x squared minus x times x minus 2. I have this function. Okay, so I would like to find the first derivative, of the function of y dy dx. Okay, dy dx. Okay, this function has two parts, two elements. The first part is x squared minus x, and then the second part is x minus 2. Okay, I would like to I will show you how to apply the product rule in this case. Okay, assume that the first one is fx, the second one is the x. We just assume fx equal to, in other words, we can write fx equal to x squared minus x, whereas dx equal to x minus 2. Okay, the dy dx, okay, dy dx equal to f x times g prime x plus gx times f prime x. Okay, that the formula how to find the derivative. So this equal to dy dx equal to fx is x squared minus x dx, the first derivative of dx, x minus 2 x. Okay, if the derivative of x is always equal 1. If we have x, the derivative of x is always equal 1. So this is equal 1 plus dx. What is dx? Dx is x minus 2. The first derivative of x squared minus x. X squared is we can apply rule of the power of x. This is 2x minus x. The first derivative of x is 1. The first derivative of x is 1. So there is the answer. X. Okay, so we can expand this answer. So this x squared minus x plus, okay, x, this part, x minus 2x squared, x times negative 1 negative x, and then x times 2x positive 2x squared, and then the last one is negative 2 okay, so it's negative 1 negative 2x. Okay, so this is not 2x. Negative 2 times 2 times 2x. Okay, that is 4x minus 4x, and then the last one, negative 2 times negative 1 is positive 1. So this equal to x squared minus x plus 2x plus x minus 4x plus 2. Okay, this is plus 2. Okay, so the answer is, we can simplify this equation. This is 3x squared minus x minus 4x minus 6x plus 2. Okay, that is the answer. The first derivative for the quotient rule. When we have two functions in one, we have two functions together, we can apply the product rule, and in order to find the answer. Okay, that is the product rule of the function. next one, okay, this is what we call as the quotient rule. Please refer to the uh, uh, page number 7. Page number 7. The quotient rule is what is the quotient rule? The quotient rule again. We have this function f y equal to fx divided by gx, the ratio function. We have this ratio function. Y equal to fx divided by fx divided by gx. Okay. Then dy dx. Okay, dy dx is quite complex here. Okay, dy dx. This equal to gx times prime x, first derivative of x, f prime x, minus fx g prime of f prime of g prime of x. Okay, that's the question. That's the question rule divided by gx squared. You can find this formula on page 7. That is the question rule. This part, when we have one function in terms of ratio, we need to apply. We have to apply this formula to find their the first derivative. Okay, for example, let's say I have this function y equal to 2x plus 4 divided by x plus 3. Okay, find dy dx. We need to find the dy dx. So in this case, we need to assume that there is a gx. Assume that fx, the numerator is fx. Fx is 2x plus 4. The denominator is gx. Gx is x plus 3. And we need to assume, we need to label what is fx and what is gx for this question before we can apply the first derivative. So the dy dx, you must follow this rule. It's quite difficult here. You must please write your answer carefully. Please focus on the gx and fx. Okay, the first one is gx. What is gx? Gx is x plus 3 times first derivative of fx. Fx is 2x plus 4. The first derivative is 2x is equal 2, because x, what then? The first derivative of x is 1. In other words, y equals when what the dy dx of 2x is 1. The dy dx of 2x is equal 2 plus 4. The first derivative of 4 is 0. So 2 plus 0 is equal to. And that's the first derivative of when we have 2x. Again, we have just to remind you, if y equal to 2x, the dy dx, the first derivative of 2x is equal to 2. Because the value of x equal 1. Okay, that's the first part. The second part is fx. What is fx? Fx 2x plus 4, and then the derivative of gx plus 3. Gx, where gx equal to x plus 3. The derivative of gx is x. The first derivative of x is 1. The first derivative of 3 is 0. So the answer is 1. Divide by gx squared. What is gx? X plus 3 squared. So we need to simplify this equation. So this is equal to 2x plus 6 minus 2x minus 4. X plus 3. To the power, x plus 4. X plus 4. X plus 3 to the power of 2 equal to, okay, so the answer is Now we can find the answer. The answer is 2x minus 2x is 0. 2x minus 2x is 0. 6 minus 4 is 2. So the answer is 2 divided by x plus 3 to the power of 2. Is the answer by using the quotient rule for the derivative. That's for the derivative of in terms of quotient rule. Okay, the next one we call it as the inverse, the derivative of inverse, the inverse function. The inverse function. In other words, the inverse, not the inverse function, the inverse, the inverse differentiation, the inverse function. Okay, okay. In other words, if dy dx is also equal to 1 over dx dy. That's the relationship between dy dx and dx dy. Dx dy. Okay, for example, let's say please remember that when we're talking about dy dx, what is dy dx? When we're talking about dy dx, dy dx is when a function is f, if for y equal to y function of x. You can say, okay, what that is, y equal to fx, y function of x. Okay, that's for dy dx. That's for dy dx. So let's but in this case, for example, let's say we have normally when we find dy dx, our function is y in term of x, y function of y function of y in term of x. We need to know what happened to y when x take certain value, when x equal to when we what happened to y when x when we want to know what happened to y, we must find the value of x. That's why in this case, y is input, x is input, y is output. Okay, that's dy dx. Okay. For example, for this okay, for example, let's say I have this function. I have x equal to 1 over 3, 1 over 3 times y to the power of 3. Okay, let's say I have this function x equal to 1 over 3 times y to the power of 3. minus y to the power of 2 y squared plus 1. Okay, now I have function x in terms of y. X equal to what? Y. Now in this case, y is input, x is output. Okay. So the question is find dy dx. I want to find dy dx. dy dx equal to 1. But based on this question, I have this function. This function x in terms of y. Okay, based on this function, we can find dx dy. Change in x divided by change in y. dx dy. So based on this, based on the rule of differentiation, dx dy equal to 1 over 3 times 3 y 3 minus 1 is 2. Okay. And then minus 2y plus 0. So the answer is y2 minus 2y. Okay, this is a dx dy. So based on this rule, in the inverse rule, dy dx equal to y equal to 1 over dx dy. So in this, based on from this example, the dy dx equal to 1 over dx dy. Dx dy. So this equal to 1 over y2 minus 2y. That's the answer. And we have a function x in terms of y. Normally, we find dy dx for function x, y in terms of x. Y equal to x. What x? What is the value of x? But now, at a certain case, we have this function x in terms of y. We can apply this concept, this inverse concept, to find the dy dx. Okay, the last about the rule of differentiation. There are quite number of rules here. Okay, the last one is, we call it as the chain rule. What is the chain rule? Okay, dy dx equal to dy du and du dx. It's a u. Dy du and dy du times du dx. U is a function of x. Y is a function of u, and u is a function of x. Okay, that's the condition. Before this, we have y is a function of x is function of y. But now we have y is a function of u, and u is a function of x. So, for example, let's say I have this function. The first function is y equal to 2u squared. The second function is u equal to 3x squared plus 5. The question is find what is dy dx. What is dy dx? We need to find dy dx. But from these two functions, y equal 2u squared and u equal to 3x squared plus 3x squared plus 5. Okay, so dy dx, we can apply chain rule. Okay, from this, this equal to dy du plus du dx. Okay, this dy du is come from the first function. The du dx come from the second function. We can combine. We can add this their derivative to find the dy dx. So from this function, what is dy du? Dy du is 2u squared. Dy du is 2. But based on the rule of the power x, the rule of the power of x, is equal to 2 times 2 u to the power of 1 times plus du dx from the u equation. For u is function of x, this equal to 3 times 2x plus 0. So the answer is 4u plus 6x. For u, sorry, it's not plus, it's times, sorry, not plus, it's at times. For u, this 4u times 6x. Okay, what is 4u times 4u times 6x? Okay, this okay. Okay, so this is what is u? 4u equal to 3x squared. Okay. For u is 4 times u equal to 3x squared plus 5 times 6x. So the answer is 4 times 6 is 24. X times 3x squared plus 5. That's the answer for dy dx. In this case, we have two functions. The first function, y, is function of u, and u is function of x. So from dy dx, we can dy dx equal to dy du times du dx. Okay, that is the rule of the chain rule of the derivative. Okay, that's basically all that's the concept of derivative. You need to know how to apply the concept. There are, I think, maybe again, I just in mind again. We have a chain rule, the inverse, the inverse, the inverse function, and then we have the quotient rule, the product rule, and then the exponential, log, derivative of power of x, and derivative constant. It's about 8 or 9 rule of the derivative that you must know for this class, in this class. Okay, that's the rule of the theory of the derivative. Okay, so the next one, okay, it is let's say I have okay, please refer to page 9. Please refer to page 9. Part A of my note. Please refer to page 9. Okay, I will show you a few examples here how to apply this quotient rule, this rule of derivative, rule of differentiation. So let's say I have this question. Okay, given fx here I have fx equal to 2x to the power of 3 minus 10x squared plus 4x. 2x to the power of 3 minus 10x squared plus 4x. Okay, the question is find or get f prime 2. That's the question. Get f prime 2, for example. What does it mean? Okay, f prime 2 is dy dx. F prime is equal to dy dx. The first derivative, x dy, x equal to dy dx. Okay, 2 when x equal to. What is the value of of the derivative when x equal to. So the first step is find the first derivative, f prime x or dy dx is equal to 2x to the power of 3. 3 times 2 is 6. X to the power of 2. 3 minus 1. The power is less than 1. Minus 220x plus 4. That is the first derivative. Now we need to replace x equal to in the question. So this equal to 6 times 2, 6 times, we just replace x equal to minus 20 times 2 plus 4. Based on, okay, the answer is negative 12. That's how to get the f prime 2. We find the value of dy dx, the value of the dy dx when x equal to. And then in this case, we can get now the number that represent the value of the dy dx of the first derivative. Okay. Okay. That's one question. Okay. The next question on the same page. Please refer to page 9. Let's say I have this question. Find the slope of the tangent line for y equal to x squared at point 1 and 1. Let's say this is the question. Find the slope of the tangent line. Find the slope of the tangent line for y equal to x squared at 1 and 1. When x equal 1, y equal 1. Please remember this at the coordinate form. This is x, and the second number is y. When x equal 1, y also equal 1. This is the function y equal to x squared. But now we need to find the tangent line. What is the tangent line? Okay, when we draw this graph, okay, I hope you still remember how to draw this graph. Let's see how to draw this graph. Okay, for example, have this okay, how to draw this graph. Okay, let's say what is the tangent line 1 and 1. Okay, I will show you the graph. Let's say this function I have okay, that's how to draw the graph. Let's say the horizontal line is for x, the vertical is y. Okay, now I would like to draw y equal to x squared. Okay, you must know what is the graph. Okay, basically we can draw this graph like this. This is a y equal to x squared. Y equal to x squared. Okay, now this part, there must be a this part. Okay, let's say for example, I would like to choose one coordinate point, 1 and 1. When x equal 1, y equal 1. Let's say I choose this point. Let's say I will need to get the point. Let's say for example, this point. X equal 1, y equal 1. What is the tangent line? Find the tangent line. Tangent line is a straight line that touch the curve y equal x squared at point 1 and 1. Let's say this is a point A. Let's say this is a point A. For example, at this point, the quadratic is 1 and 1. This is a tangent line. It is a tangent line. Okay. The question is find the slope of the tangent line. What is the slope of the tangent line? Okay. Okay, as I said earlier, what is tangent line? Tangent line is a line, it's a straight line. This line is touch the line touch the curve at that point, and at that point, the slope of the tangent line is equal to the slope of the function of the curve. In this case, the curve is equal to x squared. So, how to answer this question? Okay, first we need to find the first derivative of the curve, dy dx for x squared. Dy dx for x squared is equal to x. If y, again, I write y equals x squared, dy dx equal to 2x. This is the first derivative, and it's also known as the slope equation. Slope equation. So at this point, how to 2x is slope for x2. So when x equal 1, x equal 1, the slope equal to 2 times 1 equal 2. So at this point, the slope equal to the slope of the function is 2. The slope, this is a slope not value of y or x. This the slope of the function when x equal 1. So since at point A, the slope of x squared is 1. Is 2. The slope of x squared is 2 at point A. So at this point, at point A, there is a tangent line. In other words, the slope of the tangent line at this point must also 2. So the answer is 2. The slope of the tangent line is 2. Why? Because this tangent line touches the curve at point A, and the slope of x squared is at point A is 2. So the slope of the tangent line is also equal to. Okay, since the tangent line is also a straight line, we assume that the slope of the line is linear, or the slope of the line is equal along the line. Okay, the next question is what is find the equation. Okay, that is an additional question. Let's say I would like you to find the equation of the tangent line. Equation of the tangent line. Okay, find the equation of the tangent line. Okay, I hope you still remember how to find the equation of the tangent line is as you can see here, the tangent line is a straight line. It's a linear. The tangent line is a linear. It's a linear line. So in other words, to find the equation of tangent line, we can follow the linear formula, linear equation. We can use formula for linear equation. Okay, I hope you still remember what is the formula for how to find the linear equation. Okay, I hope you still remember this formula: y minus y1 equal to m x minus x1. Okay, that is the formula. So in this case, we know m equal to, and the point is 1. So the equation is y minus 1 equal to x minus x1. So this is equal to 2, y equal to x 2x this one, 2x minus 2 plus 1. So the answer is y equal to 2x minus 1. So this tangent line, okay, this tangent line, the line for this tangent line is y equal to, the slope is positive, but the intercept is negative. Y equal to 2x minus 1 for this tangent line. Okay, that's about the first part of the topic, about the concept of differentiation. Now you know what is the differentiation, how to relate the differentiation with the tangent line. Okay. That the next one is about the, okay, the last high order of derivative. Okay, for today, the last part for today, please refer to part B. Part B of note, part B, page number 6. Part B of my note, of the note, and page 6. We have a high order of this derivative. Higher order of derivative. Higher order of derivative. Higher order of derivative. Perbezaan pertama pada peringkat yang lebih tinggi. Okay. Normally when we if you refer to part B, part B, okay, part B, okay, part B, increasing function and decreasing function. Okay, now I would like to explain this the higher order of higher order derivative first, and then the other part I will explain next week. Okay, higher order derivative means that we can calculate not only the first derivative, not only the first differentiation. We can also find we can also calculate the second derivative, third derivative, fourth derivative, fifth, sixth, and so on. Okay, but normally we only find the first derivative and second derivative. Okay, the first derivative is dy dx. Okay, the first derivative is dy dx. Okay, the second derivative, we write d squared x, d squared y, dx squared. That is the first, the second derivative of y double prime, f double prime. That's for second derivative. For the third derivative, the first derivative is dy dx. The third derivative is d to the power of 3y, x to the power of divided by dx to the power of 3. That's how to find the derivative. Or in term, we also can write y triple prime and f triple prime of x. Okay, for the fourth derivative, okay, we just use y to the power of in bracket 4 and f 4x, or d to the power of 4 d 4 y dx to the power of 4 for the fourth derivative, and so on. Normally in practice we just find the first derivative and second derivative, but in theory we can also calculate third, fourth, fifth, and so on derivative of any function. Okay, for example, let's say I have this function fx equal to 6x to the power of 3 minus 12x squared plus 6x minus 2. The first derivative, f prime, f f prime x equal to the first derivative Okay, there is 6 times 3 is 18x to the power of 2 minus 12 times 2 is 24, 24x plus 6x. Okay, that's the first. The first derivative. Okay, for the second derivative, f double prime x equal to. Okay, we just the second derivative is the derivative of the first derivative. Then the second derivative. We just take the second derivative of the first derivative. Or second differentiation of first differentiation. Okay, this equal to 18 times 2 is 36 x to the power of 1 minus 24 minus 24x minus this minus 6. This is minus 6. 24 24 x equal 1 plus 0. Okay, 36 x minus 24. And then the third derivative f double prime x. Okay, this equal, we just take the one more derivative of for the second derivative. We just calculate the differentiation of the second differentiation. 36x plus 24. Okay, this equal to 36 x equal 1, 24 equal 0, that's equal to 36. Okay, the next derivative, the fourth derivative, f for, let's say, f for this, since there is a constant, 36 is constant, the answer is 0, and so on. F for fifth derivative would equal 0. That's the higher order of derivative. In other words, we can find in theory we can find more than one derivative, the first, third, second, third, and so forth. But in practice, especially in this class, we only focus on the first derivative and second derivative. Okay, that's basically the first part of the this topic, our class for this topic. Thank you for your attention. I think okay, that's all for today. For the topic number 6, differentiation or derivative. For the next class, for the next lecture, I will continue on this part. For this set 10. Next week we have class on 30 December. And then for set 12, next week is also another public holiday for New Year, 1st January of 2026. We have to postpone our class. I will decide later whether there are another replacement class next week, online or face-to-face. I will decide later. I will share the information to our WhatsApp group. Okay, I think that's all for today. Okay, any question before I close, before I end this our meeting?
No, Dot.
Okay, if there is no question, that's all for today. Thank you for your attention. Okay, see you next week.
Thank you, Doctor.
Bye, Doctor.